if you want to try it out, right, then there's a fifi Python library. So if you have Python, you say import fifi. If Kodo is installed, you say import fifi, and then you can play around with this. And this is the class fifi and fifi Python, what it does for you. And if you, as I said, if you go to Python, say import fifi, you can even say help fifi, right? And it tells you what it can do. It shows you the lookup tables that he has, full table, log table, optimal prime, simple binary. You can all use of that. And what you can do with this, you can just say, this is still the help information, but you can do your own lookup tables and print them out, right? And this is quite easy. If you say, I have import fifi, then the field is fifi simple online binary, so we don't want to have a lookup. We want to calculate it. Binary 4 means 2 to the 4, 16 elements. And then we have a table, and the table is empty. And then we say for E in range of order, so we go through the matrix. Then you find out that you just say, take field multiply I over R, and this is fifi, right? Because field is here, field multiply is the operation, this, and then you put it in a certain format in the table. And then you print the table. That's Python. Very easy. So, and what you see here, you don't have I and 1 printed here, but you can imagine this goes from 0 to 15, and then you multiply that. And when you look at the elements, as I said before, all the elements in this matrix are smaller than the order, right? So any operation, in this case multiplication, will lead, if you take 2 elements, will be a result out of the field. And as I said also before, if you want to get the inverse of 14, it is 3. So that is something that you can do now for yourself. For complexity reasons, I don't go higher than that, but you can try it out, right? And it's really nice to play around with it. I think you can easily also try out to make any type of equations. For example, 13 plus 7 equals 10. This is not true in the normal algorithm that we are using, but if you, where do you get it from? If you say, so here is fifi simple API import B4. This is now our field, and then you say, get me these values, A and B, right, out of the field. And then if you multiply them, if you subtract them, and you see, it doesn't matter if you plus or minus, that's the result here is the same. If you multiply 3 by, and this is not actually the same, of course, multiplication and division, there you have to look it up, you have to create the, and here you see the inverse. So the tilde 13 is equal to 4, right? Was this also here, 13? Yeah, it's 4, you see this element. So if you feel uncomfortable with these finite fields, fifi is a great help just to play around with this, right? I think there's some things, addition of subtraction is the same, and you need these kind of operations where, when you encode and when you decode your packets. Okay? Okay, with that, I would say it's enough for today. Next time, I would look into the, storage. Next time we will start with storage, right? And this was pure transportation. And when you think about future communication systems, we are going away from just transporting bits from A to B. We want to store bits in the network, we want to compute in the network, and network coding needs even the computing in the network, but it helps also to do the job. And next time we talk about storage. Storage is a field where coding was even way before transportation, I would say, applied with Reed Solomon and others, and you will see a little bit what network coding can do in the field.